Good evening, everyone. Okay, why do we need to learn SQL?
To interact with the database.
Interact with the databases. Okay. Okay. So far, we have been working with Excel as our reporting tool, right? And we were getting the data from the different sources. It could be from by manually entering it or copying and pasting it from a web page. We were doing something, right? But in the real time, usually the data is stored inside a database, right? So we need to definitely learn SQL language to interact with the database and get the required amount of data. That's what we understood. Also, let's talk about the two real-time systems. Okay, the two real-time systems that are available: OLTP and OLAP. Okay, we understood SQL is needed. Great. We want to interact with the databases, but while interacting with the databases, there are two types of systems we see: OLTP, OLAP. Right. We'll discuss that in detail. I'm eating. I think all of you have joined, right? A few of the offline participants are missing. Okay, we'll get started. Let's do one thing. I'll give you an example first, okay, about the entire database environment. And then we'll come to this real-time systems, OLAP and OLTP and OLAP. And then how these systems are useful for, the storing the data or managing the data and how to analyze the data. We'll talk about that. And then we'll use SQL Server and SQL Server Management Studio. Okay, as a couple of examples, I'll show you how to do the data retrieval. Okay, and then we will also have to install SQL Server and SQL Server Management Studio. Okay, that process is also there. Fine. Then. So before explaining this, what is OLTP and what is OLAP, let me just turn this entire database environment into a different thing. Just a second.
So, from daily, we discuss like what we are going to learn on this class from starting, so that we can note it on what the topics we are learning. So far, if you have any doubts from like in a real time scenario, according to that, we can ask you. So we do like.
First two sessions, usually it's a mix of all those examples and different doubts and all, right? But going forward, everything is like structured material is there. Going forward, each and every file is there. I'll take you through. But these examples and all, that's only for our understanding purpose, just to get a better idea. So that's the reason I'm just sharing all those examples. A few examples I can randomly give you also. Depends on the kind of question. If you ask me like to answer that, I'll give you an example. But that can't be in a structured way, but whatever the other things are there, we go step by step, and there is a material, and there I'll show you the points, what all we are going to learn for that day. But that's today, and today also kind of, you need to understand more about what is the database environment and how it looks, and a few things are there, right? So we'll just cover them in a generic way, but it's both the sessions are basically the awareness, to create the awareness about SQL. This database, environment, you can turn this entire thing into a restaurant. Okay, you can consider a restaurant. Okay, let's say if you visit a restaurant, okay, What are you to that restaurant?
Customer.
You're a customer. Can you give other few names instead of a customer? Client. You're a client to the business, right? You're a customer, but you can also use the other word as client. Perfect. Let's say you go to the restaurant and you directly go to the kitchen and place the order. No, right? No. You find a table and you sit there and someone will come to you. Who is it?
Waiter.
Waiter. Any other names? Bearer. Any other?
So.
Server. Who serves the food?
Yes.
Okay. Right. You call the server. And what is it you do? You look at the menu and you place an order and you talk to that server. Correct? Done. So once the server takes the order, goes back to that kitchen, tells that this is what we want, right? And the one who is there inside that kitchen prepares that entire, that food, whatever it is, mixing all those ingredients and raw materials, everything together. Once it's ready, what is the server job now?
So take the food from.
Correct. To, needs to take the food from there and comes to our table and serves the food. With that, your request is over. Correct. Let me take the same example in SQL environment now. You're a client, right? And you talk to the server. What is the server name? Microsoft SQL Server. You're a client and you need to talk to Microsoft SQL Server. That's the name of the server. And you want to place an order. You want to place a request. Okay. So you need to talk to that server in a language, right? Let's say if you visit a Hyderabad restaurant, what is the language that you use? Hindi. Telugu. Can't we use English? We can, to some extent, we can communicate in English also, right? They can manageable, right? You can use Telugu, English, Hindi, Urdu, any of these languages you use. What if you start talking to that server in a Spanish language? Or German? That person won't understand it, right? So that means you are using a language which is commonly understandable by both of you, right? Perfect. You talk to the server. Similarly, in the SQL server and as a client, when I want to interact with the SQL server, I need to use a language. What is it? SQL, structured query language. Okay, here I need to use a variant of SQL. What is it? T-SQL, transact SQL. So when I want to talk to the server, what is the server name? Microsoft SQL Server. I need to use a language. Which language? SQL. Which variant of SQL I need to use? TSQL I need to use because Microsoft SQL Server understands TSQL. Similarly, in the restaurant, you are using a, kind of a language to interact with the server, right? It's the same thing. It's the same thing, right? Perfect. And once you talk to that server in the T-SQL language, what is the job of that server? The server needs to go to the database. Database is our kitchen. Okay. What is that menu card? That menu card is our database diagram. Okay. Or the database documentation. Okay. The database documentation is our menu card. Looking at the menu card, we ordered, right? We placed an order for something, right? And that order is one request. And who took the order? Server took the order. And where did the server go now? To the kitchen. Kitchen is a database. You see all those, ingredients, materials, raw materials, rice, all that stuff there. There are tables, views, stored procedures, functions, triggers, all that stuff. Right? So what do we do there? We prepare all those things. And finally, we get one output, right? In the restaurant, we get the food as output. In database environment, we get a result set or a data set as an output. You can call it result set. Result set. You get that output. And the server comes to you and delivers it. Right? So now you understand the entire thing here. Right. Okay, here we go. What are we? Client. With whom we talk? Server. Which language we use? A commonly understandable language. What is it? SQL. Which variant of SQL? TSQL. So do we have the other variants also? Yes, we have MySQL, we have Oracle SQL, we have other few variants of SQL. But here we just need to learn only TSQL because Microsoft SQL Server understands the TSQL. What if I need to work with other variants of SQL? No need to worry because 95% of the commands in SQL across all these different variants are same. That 5-10% here and there you will have to manage, but the rest of the things are same. You got the point? Now you understand this? Perfect. So whatever the restaurant example that we just used, if you can remember, most of your questions can be answered going forward. Right? We are a client, we talk to the server. Server job is to go to the database, get the request processed, get us the data, share the data set or the result set with us. Why do we need that result set? Because we want to analyze that result set to understand what's happening in the business. Done? Perfect. Right. For this, in the real time, we have two types of systems, OLTP and OLAP. What is OLTP? OLTP is online transaction processing. OLTP is online transaction processing. Okay, OLTP, online transaction processing. What is OLAP? Online analytical processing. Okay, OLTP, OLAP. Done. So why do we need two types of systems, and what is the main purpose of having these two different types of systems? Okay, let's try to understand them. Why do we need two different types of systems, OLTP and OLAP? OLTP, as the name says, online transaction processing. This is meant to manage all the transactional data, the database modifications. The focus of this system is to perform insert, update, delete. Insert, update, delete. These are the things this system does. Okay, insert, update, delete. And if you look at it, it's an online transaction system, manages the database modifications. Insert, update, delete are the main functions of this. OLTP and its transactions are original source of data. Got a question, original source of data. I think you may be confused, like, is there any duplication in the data? Okay, kind of. I'll explain this. OLTP has short transactions. OLTP takes less time. OLTP has simpler queries. But looking at all these things, looks like it's a very simple system, easy to work with, right? And why don't we go with always this system only? Why do we go with the complex one? Here we go. These two systems are meant to do two different things. So I'll give you a simple example here. OLTP, the best example is you can take a billing counter example. Let's say you go to a shopping mall, there is a billing counter. That billing counter is connected to the OLTP only. OLTP, online transaction processing. What happens with the billing counter there? What happens?
They'll scan
They scan the barcode. Okay, what else?
They record
Swipe the card.
payments,
They record?
payments, collect the payments.
Okay.
the bill.
They'll give the bill. They'll collect the payment and they will give the bill. Right? Perfect. Okay. Here we go. What happened technically there?
Transaction.
In that entire process, what happened?
The price is price.
Price?
With the help of a card.
With the help of a barcode. Okay. That's it. Nothing else happened.
They are inserting the data.
Understand that and the billing counter, at the billing counter, there a transaction took place. It's a transaction that's what is done in the billing counter. There is a transaction that took place. Okay. In the billing counter, what happens? Let's say you give the products and they scan that barcode and one, the quantity and all that stuff will appear there and they say the bill amount and you give the cash or card and they do that rest of the things and a bill gets generated. That means one transaction is done there. this transaction gets inserted into which system? The OLTP database is there, right?
Yes.
There it gets inserted. Insert. What is insert? It is as good as creating a new record. Record is nothing but a row. You created a new row, so and so customer bought so and so, things in this so and so transaction ID. This is the total amount paid in cash or paid by card, whatever it is. Right? All that information will be recorded as one transaction. It is called insert statement. So insert thing happens. Okay, done. While that person is generating the bill, okay, found your mobile number, okay, and he asks like your mobile number is 8686836838. Is it correct? Then you said no, that's not the mobile. That's not my mobile number. Please update it. Change that mobile number to 8686836999. The person will be able to do that.
Yes.
Changing the mobile number of the customer, yes, because it's not so sensitive data for them. So yes, it is possible for them to change the mobile number. So what kind of a transaction took place there? Update took place there. Then you found two addresses. They are linked with your ID. One is your office address, one is your home address. And you say that, no, I've stopped working with that office and please remove that office address and just keep only the home address with you. Then can they delete that extra address? Yes. What kind of a transaction is it? Delete. So the OLTP, the best example is the billing counter. There, what kind of transactions they take place? Insert, update, delete. Insert is to create the new records. Update is to update the existing records, and delete is also to delete the existing records. Okay. So what is this word? Okay. Insert, update, delete is okay. But what is this word? Original source of data. Is there any way that the things will be duplicated? Yes. Understand this. When you buy something, that's where the very first transaction take place. That's the original. From there, the same data will be copied into different other systems, other databases, the same data. You get a question, why do I need to copy that data into some other system? No, it's already recorded. It's already there, right? Why do I need that? Okay, I'll give you a simple example here. Why do we need to do that? Let's say you're working with a supermarket, okay, and they have the branches across India, okay. So Hyderabad, entire Telangana, AP, and all the different branches, there is a data center, okay, one OLTP database that is available. That is there in Hyderabad itself, okay. Chennai, Tamil Nadu related, all the transactions are there, are recorded in a Chennai database, okay. All those things, as soon as they take place, the system is recording that data in that data center or a database, you can say. You have one more in Mumbai, one more in Delhi, and all these data centers, they are covering all the India transactions. Okay, there is a CEO who sits in Mumbai location, wants to understand what happened yesterday, but the day across all the businesses, okay, that are located in different states. But the problem here is, your CEO cannot get a consolidated report because this data is located in different databases. Each and every city has their own database there. Okay. Then if your CEO wants to understand what all happened yesterday, then what is it we need to do? We need to somehow get all these different databases data into a one place. This place is called data warehouse. Data warehouse. Probably you would have heard this word, data warehouse. What is this data warehouse? Data warehouse gathers the data from different OLTPs. Multiple OLTPs data becomes input to the OLTP. Okay, done. So it's basically for the database modifications. Insert, update, delete are the commands that we use. And OLTP data is always the original source of the data. Okay. And OLTP has short transactions. Let's talk about that billing counter only. Okay. If no one is there and you go to the billing counter and you have your cash or card ready handy, okay, how much time would it take to complete that bill? The transaction, how much time? maybe 5 minutes max. If no one is there, like if you are waiting in the queue, that's a different story. But within 5 minutes, everything will be done and the products will be packed and will be handed over to you, right? Why? Because these are short transactions. You don't need to wait. OLTP transactions. The other best example is ATM. ATM also, it's the best example of OLTP only. What happens there in the ATM? Insert, update, delete only, right? So when you go to the ATM, what is the time frame that you expect? Like how much time would it take to complete one simple transaction like withdrawal of money?
2 minutes.
2 minutes, maybe sometimes less than 1 minute, depends on the speed, right? But usually that is also a shorter transaction only, not too long, right? Okay, so these are short transactions because of which it takes very, very less time. And also you have in OLTP, you usually see simpler queries. OLTP. Why these are simpler queries? Because you are performing what? Insert, update, delete. Insert, update, delete are considered as simpler queries. You can insert something, you can update something, or you can delete something. They are the simpler queries. What is data normalization and integrity? I'll explain that in a next example. But for now, you just understand up to this the queries types. Basic is OLTP is to manage the database. And then what is the focus? It does this insert, update, delete. Okay. And the data, when it comes to the data, OLTP data is the original source of data. Then we have the the transactions. It has short transactions and the time it uses very less, and the queries are simpler queries. Okay, OLTP. ATM also OLTP only, right? And this OLTP system is mostly used by the data entry operators only. Can you tell me why the data entry operators only use this OLTP? What do? They insert, perfect. They insert, update, delete them using the OLTP systems only. Insert, update, delete. Okay. So OLTPs are mostly used by the data entry operators. Then I get a question here. Who is a data entry operator? Who is a data entry operator?
Biller, the one who bills.
Who is a data entry operator?
When does the data?
Who maintains the data? Okay. Who enters the data? Enters the data. Okay. Right. A data entry operator is who enters the data. Perfect. Now tell me, are we data entry operators? Are we data entry operators or are we analysts? Analysts. Okay. So we don't do any data entry operation?
No.
Okay, fine then. Great. From the morning, you did any kind of a GPay transaction or a phone pay?
Yes.
Can you tell me, is it a data entry operation or a data analysis operation you did?
It's an entry.
Oh, you entered the data then?
Entry, yes.
Transaction.
It's a transaction.
It's a
Perfect.
transaction.
You entered the data and you completed the transaction.
So they
Perfect. Inside, we use an app to do that. Instead of a SQL command, you used what? You used an app, and using that app, you are able to enter the data and you are able to successfully complete one transaction. So understand that we all do data entry operations. We all do that, right? The different data entry operations every day we do. Okay. Don't think we always do the data analysis work only, but in the organization level, yes, we do the data analysis, and sometimes it is also important for us to do the data entry also. Data analysis is our primary focus, but sometimes we do the data entry also. Depends on the kind of thing that we need to do, right? So understand this. Data entry operation doesn't mean that, system sitting on the system and doing something. We all do a lot of data entry, and all these applications, they are connected to what? They all are connected to OLTP only, online transaction processing systems. Okay. So the queries are simple. Insert, update, delete are the ones we perform, and they have shorter transactions, and they can take very, very less time. They take very, very less time. Okay. These points are okay for the OLTP purpose.
Yes.
Done.
Sir,
Yeah.
we are using the word system, right?
Mm.
What we can consider the system is like a database or server, or it can.
Okay, a system is with a combination of a server and a database. It's one system, right? That has a server in it and a database in it. It's one system for us.
Combination of database as well as server.
Server application as well. Okay. Correct. Then we have OLAP, online analytical processing, as the name says. What is the purpose we use this? The previous system transaction processing, OLTP, why do we use that? This is to, manage the online transactions, right? The different transactions, right? Perfect. The next one is OLAP, online analytical processing. And what does it do? If you look at this, it is an online data retrieving and data analysis system. Online data retrieving and analysis. Extract data for analyzing that helps in decision making. You see that? We extract the data. What is the purpose? Why do we extract it? Because we want to analyze and help the business to take the right decisions. That is the purpose we use the OLAP. OLAPs, you do not see any directly data, a direct data is entered into OLAP. Why? Because OLAP gathers the data from the multiple OLTP. So that is the reason it clearly mentioned here. Different OLTP systems, different OLTP databases become the input to the OLAP. OLTP databases become the input to OLAP. Okay. So how do we get multiple OLTPs data into one OLAP? You can consider this OLAP as your data warehouse. So if you have 5 databases data and you can combine all of them into a single place, right? That multiple OLTPs data as it is getting into one OLAP, and if you store all the data into a single space in one location, you can consider that as a data warehouse. OLAPs, they manage the data warehouses. Okay. What is the primary focus of OLAP system? This is to help the business to take the right decisions. Okay. Help the business to take the right decisions. Okay. How do we get multiple OLTPs data into one OLAP? There is a process called ETL. What is this ETL? ETL is to extract, transform, load. Extract the data from OLTP, transform the data into the required shape, and load the data into one data warehouse. Okay. Extract, transform, load. Okay. There is a role called ETL developer. ETL developer role is something different from the reporting developer or report developer or reporting analyst. The reason being, our job is to get the data from the different warehouses or different tables in the warehouse. And once the data is with us, we can create the different reports. But ETL developer job is to interact with each and every online transaction system, OLTP, interact with it, get all the data into one warehouse. What is the advantage of keeping all the data into one warehouse? Can anyone tell me? Why do I need to keep all the data into a one warehouse?
To analyze the data.
To easily analyze the data. If the same data is stored in multiple databases, it's like a time-taking one, right? I need to go to each and every database and I need to extract the data from there. But these ETL developers, what do they do as they, do the jobs and the data loading jobs, ETL, the last L is for the loading only. So the job of these ETL developers is to bring all the different data sources, data into one place. That is how the OLAPs, they get the data. The transactions are not directly recorded inside OLAP. Okay, where the transactions are recorded in the OLTP, they are recorded, but ultimately the data will go where? To OLAP system. Okay, online analytical processing. Okay, there you see that these transactions are long transactions. Okay, the transaction time also takes a bit more time, and finally they are complex queries. You definitely get a question here. Why the complex queries? You know, the left side one, we have the OLTP and that has a simpler queries. Let us go with that one only, right? Why do I need to write the complex queries to, you know, do something with the databases? I can always go with the easier queries. But here we go. The complex queries are meant to do some, you know, something which is like a little tricky one. The regular queries, you know, the easier ones cannot get you that analytical related answers. Okay. There are so many aggregations, grouping, having, and so many other kind of things are there. You cannot implement, you know, these kind of things in OLTP because OLTP job is not for reporting. OLTP job is to perform the data, you know, retrieval, inserting, or data inserting, updating, delete only in the OLTP, online transaction processing, right? GPay transaction, okay? GPay. So is it the example of OLTP or OLAP?
OLTP.
OLTP.
Perfect, because you are doing one transaction there. Excellent. TP. But yeah, here we go. You want to analyze some data, last 10 years data you want to analyze. Then what kind of a system you need to depend on? You want to analyze, okay, you don't want to insert, update, delete, but just you want to analyze.
OLAP.
Perfect, all the data is there in a single table, and then from there you can get the required amount of data, and then you know, once you get the data, you can start the analysis process on that. Okay. Which team helps us to get that multiple OLTPs data into one OLAP? Which team? ETL. Perfect. What is the full form?
Extract,
Extract, transform, load.
Correct. Extract, transform, load. We extract the data from the you know, the different OLTPs, right? They transform the data into the meaningful shape, the format of the data, and then finally they load the data. ETL, extract, transform, load. There is a, you know, separate role available, ETL developer. Okay. Their job is to build all these kind of pipelines and get multiple OLTPs data into a single OLAP. Right. So two systems are there. I'm all okay, but I'm still confused because, you know, on the left side, you are saying it is simple, right side, you are saying it is complex. Then we can always go with the OLTP transactions only, right? Hold on. OLTP focus is only to insert, update, delete. If you want to take any decision, then definitely you need to perform what? A select query, and you need to extract the data. That is not possible there. Okay. Of course, you can still do that. But let me explain you practically what will happen if I keep only one system in the real time. Just only one system in the real time. Forget about OLAP for some time. Imagine you have only one system. What is that one system that we have? OLTP. What is the job of OLTP? It is to manage the database modifications and all. But we don't have any OLAP. OLAP, why do we use it? For the analysis purpose, we use it. But let's assume that there is only one system. Forget about the OLAP system. We have only OLTP. Now all the users are dependent on OLTP only. What is the primary role of OLTP? What is right? Insert, update, delete. And there may be thousands of users. They may be logging onto the system and they are buying something, they are updating something, they are deleting something. Multiple things are parallelly happening there. Okay, in the OLTP system. But here's the challenge. Of course, it will be able to handle all that. But suddenly you want to place an analytical request onto the OLTP. Analytical request also, data analysis related request also, you can place on the OLTP system. Possible, okay. Because it is also a computer, and if you ask something, it will answer it. Okay. So then what will happen, you know, because this OLTP system is already busy in serving a good number of thousands of customers. Suddenly, let's say if you ask a question related to analytics, then it will struggle a bit. That's when you see the server related latency issues, and you will have to wait for the server to respond. But otherwise, usually when you ask a very tricky question while it is trying to do something else, and it will spend a few more extra seconds of time, and then it gets you that output. So understand that OLTP transactions are easy, they are simple. Insert, update, delete is the one we use. But when it comes to this OLAP, it is just to perform the select query with the whatever the function that we want to use, we can use it and we can get the output. But the challenge is in the real time, if you have only one system, if the other system itself is not there, then you will have to depend on the same system. Now, both your data modification related requests and as well as data analysis requests are going to the same system. So with that, I think you understood the entire context of this example, right? Let's assume that you have only one system that is taking care of both data base modification, activities and as well as your data analysis activity. Only both of them are managed by only one system, which is OLTP now. Okay, what is the primary role of OLTP? It is to store the data, right? Insert, update, delete, right? Okay, fine then. To make it more interesting and easy to understand, I'll give you a small task. This is what you need to do. Take a rough paper. I'll ask you to write a few numbers and write. Okay, do that now itself. Take a rough paper, right? Any kind of a paper you can write this. Yeah, I'll tell you the numbers. And you need to write. Right. Okay, here we go. Write these things. 14. Okay, one by one. Okay, one after the other. Below you can write it better. 14, 18, 22, 16. Okay, so I'm repeating these things. 14, 18, 22, 16. Oh, okay. So the second number I said 18, right? 18. Okay. 14, 18. What is it? 14, 18, 22, 16. Okay. Tell me what kind of activity you did just now. If you convert that into database language, you wrote it on the paper, right? What did you do there?
Entry.
Data entry.
Insert.
Insert.
You inserted the data into the database table. You used insert there. Okay, insert. Okay. The second number I said 18, right? Okay. Cut it off and put it as 20. Strike it off. Okay, what kind of action that you did?
Update.
Update. Perfect. Perfect. The last number I said 16, right? Delete that, we don't need it. Okay. After doing these modifications, tell me what is the list that you are left with?
14,
14,
20, 22.
20 and 22. Right, perfect. That is the final data that we have. Okay, great then. So the last number that you wrote 16. Yes. Now write 18. 18. After 16, write 18. Okay, I want you to do the sum of first and second number. Now the first and second numbers are 14 and 20. What is the sum? 34. Okay. Okay. So write 26 at the end. Okay. Tell me the sum of third number and fourth number. Also write 38. One more number. And this time you need to tell me the sum of first four numbers. Okay. Write 42 as one more number. And this time you need to tell me the sum of first six numbers. Why you are not saying sum?
is difficult while inserting.
Why it is difficult? When I asked you that the first two numbers 12 and 20 you are comfortable, right? Then after that I asked you to get me the sum of the second and third number or first four numbers or first six numbers.
It depends upon the data size, like,
But I gave you a very simple requirement only, right? I just asked you to do the sum.
but initially, like, initially you haven't mentioned, right, like we need to maintain the sum.
But whenever I'm giving you the number, I'm asking you to, okay, get me the first four numbers there, sum, or get me the first six numbers sum, right? What are the two things happening here, One thing, you are doing inserting as well as you are also trying to do a data analysis job by implementing a function on it, right? Your mind is unable to handle both of them. Parallelly, I'm telling you the numbers and as well as I'm saying, okay, do the sum of these three, do the sum of those four. And while you are trying to do that, I'm giving you a one more number. Again, you are focusing on entering the data and you are forgetting what is the total of this one. Now we are getting it. What if let me make it simple. What if I do you to enter the data, you to get me the sum? Is it okay?
Yes.
Now you find it easy, right? Why? Because your responsibility is now in split or divided so that one system is taking care of only the doing the data entry and modifications, insert, delete, update and kind of thing, and the other system is only taking care of doing all those calculations. What is the average effort? What is the average of it? What is the maximum of it? Minimum of it? Sum of it? Count of it? All those things you are doing. Now you understand why we need to have two different types of systems in the real time. One system is already doing a lot of activity by interacting with the customers and taking all the customer orders and processing them. The other system job, which is the analytical work, you cannot leave it to the OLTP. OLTP, of course, it is like a computer, it can also do that, but it's already doing a lot of work in order to serve your customer requests. On top of that, if you start giving the analytical requests also, the customers will fail latency issues. Yes or no? Right? I'm giving you the numbers and I'm asking you the sum, and sum it is taking for some time to calculate and then give me back. And similarly, if a customer is ready to book something, but your server is not responding. Okay, I'll give you a simple example. These days, because of the internet availability, everyone is like expecting things to be done in seconds. Let's say you are trying to book a bus ticket. Let's say you opened Abibus. Okay, you opened it, you chose the bus, and almost all the bus platforms they maintain the same buses and everything is available. The price may be varying little here and there, depends on the discounts and all. Fine then, one bus is there. Okay, ticket price is 500. You opened Abibus. You're trying to book it, but that application is taking so long time to process, right? Couple of times you tried it, but towards the end, like while you are trying to make the payment, the page is getting expired and it is saying you cannot book this ticket. You tried it twice. So what is it you do? You wait for more half an hour and then attempt the ticket from the same app. Yes? Yes, sir? Perfect. You open Red Bus. Right? And you see the same bus, same time, same price also. And you book it. Right? What happened in this example? Abibus lost some profit. The transaction would have been done on Abibus platform, they would have earned something. So that means customer is the price. Your analytical requests and all, they can come later. So that's the reason we do not combine the analysis related things with the transaction processing. Two systems to be separated. You're getting the point now? So customers are the top priority. If you are, making them wait for 1 minute, 2 minutes here and there while booking a ticket, they will lose the interest and they will switch to other application, right? So understand that, right? So that's the reason usually the analytical requests are not processed using the OLTP. What is that we do? Next day, if the CEO wants to understand what's happening in my business, during the midnight, the ETL developers gather all the different OLTPs data and put together into a data warehouse. And from there, the CEO can directly see all the data, what's happening, what happened yesterday. But we do not engage our OLTP to serve the analytical requests. Of course, it can do the calculations and all, but that is not recommended. You got some idea now, right? Why don't we maintain the same thing? Now you understood OLTP and OLAP, OLTP, which teams they use?
Data and
Yes.
Yes, the data entry teams. OLAP?
Analysis. Analysis.
Data analyst.
Data analyst they use. Okay. So this is one of those things you need to remember. Okay. Data analyst work will start once the ETL developer job is done. Is it a true statement? Once the ETL developer job is done, then the data analyst job will start.
Yes.
Yes, because the ETL developers are the one, they gather all the data from the different OLTPs and load them into a data warehouse, right? Once they give us the confirmation, then only we can start working on the data warehouse on the analysis part, right? Okay. So our job starts after the data, gets loaded into a data warehouse. So usually we get a notification email saying that the data warehouse now been updated and please start processing the reports. Okay, we usually wait for that email confirmation, or otherwise, sometimes you will get the notifications. If the company has that setup in the Teams, there will be a notification trigger saying that your data is now ready and you can start, refreshing the reports. So these kind of things we usually see in the real time. So data warehouse confirmation should come, then only we need to run the reports. What if we run the reports without getting the confirmation from the data warehouse team? What will happen? We still get the outdated data only there. We still get, day before yesterday's data. Yesterday's data you can't see. Got the point? Right. Perfect. So the last two, data normalization and data integrity. Data normalization and data integrity. These two are very, very important, right? But to understand this, data normalization and data integrity, we need to do small exercise here. Okay, data normalization and data integrity. Okay, tell me this. You have a table here, right? You have a table here. Using this table, can you answer this question like total salary paid by the department name? Can we do that? Total salary paid by the department name. Can you answer it? Why? How? How is it possible to answer this question? Total salary paid by the department name. Salary column is there and department name is also there. Excellent. If both the columns are available there, then yeah, you can create a pivot table. Total salary paid by the department. Done. That's easy, right? Can you tell me total salary paid by the job? Is it possible?
Yes.
Total salary paid by the job. Is it possible?
Yes.
Yes. Why? Because you have the job column there and the salary column there, right? Can you tell me the maximum salary paid by the department? Is it possible?
Yes.
Yes, because department column is there and salary. See, whatever the questions I'm asking, these are the analytical questions, right? But I'm using sum and average kind of, but you can see complex things also going forward. But you need to understand one very important thing here. In the real time, the data is not available in this shape. In the real time, the data is available in this shape. Now you take a look at the highlighted table. Can you tell me this total salary paid by the department name? Is it possible to say that answer using this table? Total salary paid by the department name. Is it possible?
No,
No. Why no?
we don't have department columns.
Correct. Yeah, we don't have the department name. We have what? Department
ID.
ID only. Right? Okay, I have one more. Total salary paid by the job ID. Is it possible? Yes, job ID.
Yes.
But when you present total salary paid by the job ID, your management won't be able to understand what is that 1, 2, 3, 4, 5. But if I ask you, can you tell me what is the job ID 1? Which designation is it? Manager. How do you know? How do you know one is manager?
In the designation table.
Oh, okay. So that means you are looking up this one in the designation table. That's how you said it is manager. right? So that means whatever the value that you have here, you need to look up that value in the designation table to find out what is the job of it, right? In the real time, almost all the times the data is stored this way only. The data is not stored in a single table. If the data is stored in a single table, it's easy, yes or no? Because everything is there in one place. But in the real time, the data is stored in multiple tables like this. There is a reason why we do not prefer storing the data in a single table, right? If you are storing all the data in a single table with their physical values, it's going to increase the table size significantly. Why? I'll tell you. Here, 1 is there. 1 represents what? Manager, right? Okay. If I give you a pen and paper and I ask you to write 1, I'll ask you to write manager. Which one consumes more ink? Writing 1 will consume more ink or writing manager will consume more ink?
Manager.
Manager, perfect. Which one consumes more time? 1 or manager? Manager, writing manager. But instead of writing the manager every time, if I ask you to write 1 only, just whenever you hear the word manager, you just put 1 there, right? Do you see any ink saving and time saving there?
Yes.
Yes. Right? Yeah. The same concept is used in the database side also. Instead of saving entire data in a single table, what is that we do? We split the data into multiple tables like this. With the help of keys, we can join the data back again if needed. Okay. So this process is called data normalization. What is data normalization? It's the process to split a big table into multiple small tables. It's a process to split a big table into multiple small tables. It's a process to split a big table into multiple small tables. So what is the advantage there by splitting the data into multiple small tables? You get the dimension tables and fact tables. As a result of the normalization, what type of tables you get? You get 2 types of tables. They are dimension tables and fact tables. They are dimension tables and fact tables. Okay. So what is a dimension table and what is a fact table and what is the advantage? Okay, here we go. In all these tables, as we are using only the keys, okay, we call them as keys, okay? So the job ID, department ID, all these things are keys, right? So we have a job ID here, right, which is 1. It's a key for us, right? As a result of the normalization, we get the data into multiple tables and we can combine the data back into a single table with the help of keys, right? There are primary keys and foreign keys. We'll talk about that shortly, okay? Primary keys and foreign keys. But remember, these keys will help us to get the data back into a single table, right? And these tables are 2 types. What are they? Dimension tables and fact tables. Okay, let's talk about a fact table first. What is a fact table? Fact table. Okay, and the other tables are dimension tables, dim tables. You can simply call it as dim or dimension table. Designation table is also a dim table. Gender table is also a dim table. Right. The 3 on the right hand side, these are the dimension tables and this one is a fact table. What is a fact table? I'll give you the definition, easy definition, okay, to understand. A fact table is the one that holds numerical data. And that column allows you to do the sum. Okay. A fact table holds the numerical data. At least 1 column should be there that should allow us to do the sum. What is a fact table? A fact table contains numerical data and that column, at least 1 column should be there to perform calculations, especially the sum. If you can perform the sum, okay, if you can perform the sum, you can consider that as a fact table. Done? Okay. Right then. So we have a fact table here, which is employee table. I get a question here. What is the definition? I said fact table that should hold numerical data, and that column, at least one column should allow you to do the sum. Okay, tell me something. In this entire table, do you see at least one column that allows you to do the sum? What is it?
Age.
Salary.
Okay, tell me, hold on. Age column, can I do the sum?
No.
Yes, sir.
No, also.
Can't we do the sum of age? Think.
No, sir, there is no use of sum of,
Right.
We can do, but it was not meaningful.
You should do the calculations, the sum and all, it should make some sense. Then only you can do the sum. Otherwise, no. Age column is not a numerical column. Of course, it is the data type wise is a numerical value only, but you cannot consider that age column to do the sum because sum of age doesn't make sense. Okay, done. Perfect. Okay, what is that one column or two columns that you see in this table that helps you to do the sum and the sum makes sense? Which one is it?
salary.
Salary column, excellent. Salary column is a numerical column as well as you can do the sum and the sum makes sense. This helps us to understand what is the total salary to be paid. Okay, done. What else?
Only salary.
Commission is there. This column also. Date of joining. Okay, date of joining. Can I do the sum of date of joining? Sum. Can we do the sum of this? Okay, you're saying gender ID. Okay, can we do the sum of gender ID? Okay, can we do the sum of mobile numbers? Can we do the sum of employee IDs? No. Can we do the sum of job ID or gender ID? No. IDs, though they are numbers, you can't do the sum. Yes or no? Right? Okay. So employee table is a fact table. Employee table is a fact table. Right? Because we have at least one column, we thought like at least one column should be there, but there are like a couple of columns, they are numbers, and as well as I can do the sum, it makes sense, right? Okay, tell me employee ID, can I do the sum?
No.
No. Doesn't make sense, right? Okay. So now you know why do we call employee table as a fact table, right? Okay, let's take a look at this department table then. Department table is a fact table, yes or no? No? Okay, why no? I see one numerical column, right? I told you if the numerical column, at least one column is there.
Doesn't make sense.
Exactly. Just because you see a number, you can't do the sums. Department ID is not a numerical. Of course, if the data type wise, it is a numerical data only, but it is not eligible for sum because it is like an ID. So departments table is a dimension table. Okay. Designation table, gender table, all these things are dimension tables only. Those numbers that we see here only for the relationship purpose or the join purpose we use. You got the point? Right?
Excel we call them as measures.
In fact table, in Excel, we call it a measure column. Measure. Okay. Other columns are locations, department names, department IDs, all these things are dimensions. Okay, perfect then. Right, here we go. Going on to our relationship here. When you want to use department ID 10, where do you see the department there?
Department table.
Correct, in the departments table. Similarly, if you want to know what is the job ID 1, where do you see that?
Designation table.
In the
Designation.
designation table. Excellent. Okay, gender table. That's it. Easy to understand, right? And in Excel, if you want to fetch what is that job, okay? What is the designation, okay? Job. What is it I write? for using this designation ID at the job ID, I want to see the job description or the job text there. Which one? Excellent. VLOOKUP. Lookup value is this. Table array is this. Raise it. Second column 0. Right? Drag it down. Done? Perfect. You know that already, the VLOOKUP formula, right? Okay. So the same thing in SQL, if you want to do it, is a join. It is a join. Join. In Excel, we do the lookups. In SQL, we do the joins to get the data from the other tables. Why these joins play a very crucial role in the data analysis? Because our data itself is available in multiple tables. Why we had to split the data into multiple tables? Because of the normalization process. Why we had to perform the normalization? Because we want to reduce the redundancy and inconsistency issues. What is redundancy? The same value is repeated for multiple number of times. Instead of typing manager, manager, manager for multiple number of times, how did we reduce that redundancy? We just assigned a number value there as 1. 1 represents manager, where whenever you in that column, when you put 1 there, how it is treated? It is treated as a manager only. You got the point?
Yes.
Right? Now you understand what is data normalization?
Yes.
It is a process to split the data into multiple tables. And why do we perform the data normalization? To reduce the data redundancy and inconsistency issues. And as the data is split into multiple tables, each and every table gets one unique identification key, which is called primary key. Okay, we'll talk about a primary key and foreign key shortly. Okay, all of you are okay so far. Now you know what is data normalization, right? What is data normalization?
To store data in
Multiple tables, and how this data can be joined back into a single table with the help of joins. Right? Why do we have to split the data into multiple tables? Because to reduce the redundancy. To reduce the redundancy and inconsistencies. To reduce the redundancy and inconsistency. Okay? Fine. And also to maintain the data integrity. Okay? Also to maintain the data integrity. Fine, then we have the keys here. We understood what is data redundancy and reduce the inconsistencies are to maintain the integrity. Let me show you one interesting thing here. If I type 60 here, tell me, is it a valid department ID or not?
No, sir.
Why not?
There is no
Hmm.
department.
Exactly. When you look up this value inside the departments table, this fails. It says that, okay, there is no department with that 60 number. Then it won't accept it. It also helps us to maintain the data integrity. A department ID which is not present in the departments table, you cannot use it in the employee table. Okay, is it fine so far? Right, how it maintains the data integrity and how it avoids or reduces the redundancy and inconsistency issues. Are we okay? Right, just save this. I think now you know these words, what is a primary key and a foreign key. Right, once you perform the data normalization, what is it you see? You see primary key and foreign key only. Let us talk about what is a primary key and foreign key for some time. Right, you take a look at this department ID. Department ID column in the departments table is a primary key. How do you know? Because can this be repeated? Department ID in this table? No way.
No.
Okay. Similarly, job ID in the designation table is a primary key. Similarly, employee ID in the employee table is a primary key. It's as simple as that. So what is the behavior of a primary key? Understand that it is always unique and cannot be null. Remember, two rules are there for the primary key. What are they? It must be unique and cannot be null. So what is a primary key? A primary key must be always unique and cannot be null. Okay, what is a primary key?
Unique.
Unique and
Cannot be
cannot be null. Okay, let me ask you a few questions. Just minimize this. Few questions are, you understood normalization and integrity, right? So data normalization, OLTP, usually it is normalized. OLAP, it is not that much normalized. Because in OLTP, the data is split into so many tables, but in OLAP, we try to bring the data as close as possible. Can you tell me what is the reason? Why in OLAP, we try to bring the data as close as possible? Why? Because OLAP is used for what? Analysis. Nothing but if the data is available in the closest format, then it is easy for us to interact with the tables and get us the data. Right? As a result of the normalization, you get two types of schema designs, okay? Okay. You see the star schema design like this, where we have a fact table which is surrounded by dimension tables. Using the common keys only, we join them, okay? Revenue table, dealer ID is there, dealer table, dealer ID is there. Branch table, branch ID is there, revenue table, branch ID is there. So basically, you need to find that common key to relate that those tables, okay? So the schema designs are two types we see. One is a star schema design, the other one is a snowflake. In the snowflake schema, I think you can easily figure this out. In the snowflake schema, you have a lot of normalization is done. Multiple tables. Okay. This is the best way to store the data, no doubt about it. Why? Because it occupies very less space. Right? You know that, right? Instead of writing the physical value, you can assign a key and you can store the key value there. Right? But when it comes to the reporting, the star schema is very much recommended. When it comes to the reporting and analysis, star schema is very much recommended. Why? Because all the tables data is available in the close, close format, right? Right. Okay. So two types of schema designs: star schema and a snowflake schema. Right? Why do we get them? Because our data is normalized. As a process of normalization, what is it we do? We split the data into multiple tables, right? Okay, you understood normalization and integrity. The other thing also we understood, right? A department ID which is not there in the departments table, you cannot use the department ID in the employee table. Data integrity. If something is there in the department table, the same department IDs only can be used here in the employee table. This is how the data integrity is managed, is maintained. Okay. Fine then. So we understood all these things. Now we have a few questions. I think you are comfortable with this key called primary key.
Yes.
What is a primary key?
It is unique and cannot.
It is unique and not null, right? Can you tell me a few examples of primary keys?
Employee ID.
Employee ID,
Department.
serial number, department ID. Okay. What else? What else is a primary key? Online participants, please tell me a few primary keys, please.
phone number.
Phone number, okay.
Bank account number.
Bank account number, excellent. Yeah.
PAN number.
PAN, okay.
The account number.
Vendor account number, okay. Online participants, a few examples, please, of primary keys.
Serial numbers.
Serial numbers, okay. Okay, fine then. Yeah, online participants, any? Which one is it? Sorry, can't hear you clearly. You can use the chat window if you want. Okay. Fine then. Yeah, license number. Perfect. You can consider license number as a
Aadhaar
primary.
card number.
Aadhaar card number. Excellent. Yeah.
Even passport.
Passport,
Asset ID.
asset ID, customer ID. Awesome. A good number of examples, right? Okay. I'll just open one file. I think you all can easily answer this then. Let's see how many of you will answer it correctly. Have a supporting file, primary key. Okay. Okay, here we go. Take a look at this table and tell me what's the primary key here.
Employee ID.
Employee ID, perfect.
Pay ID.
Oh, hold on. Usually a table, you see only one primary key. Identify one primary key there.
Employee ID.
Employee ID is a primary key. Okay, online participants, what is your thing? Is it
Employee ID.
employee ID is a primary key because just before this we discussed, right? Okay. Okay, here we go. What is the behavior of primary key? Unique?
Cannot be null.
Cannot be null. Okay, excellent. So the employee ID is unique and cannot be null is what we are thinking. That's the reason we all said it is a primary key. Now I have a question. What is it? Salary is also considered as a primary key?
Unique and,
Okay, so unique and in this data, this is, someone is suggesting that even the salary can be, considered as a primary key because it is also looking like unique and, not null, right? Okay. So tell me something. Let us take a real-time use case, okay? Salary, okay? So if you consider salary as a primary key, what is the behavior of a primary key? One thing, it must be unique, nothing but it can't be duplicated and it can't be null. So, do you mean that your salary in your organization, others can't get the same salary? Then can we consider this as a primary key? So, no. So that means others also can have the same number, right?
There is a probability.
High chances. If it is like a very big company, thousands of employees are there, not from your department, some other from some other department will have can have the same salary number. Then you cannot consider that as a primary key. Everyone understood, right? The concept why I'm saying it is not a primary key. So you cannot mark that as a primary key. Okay. So what else is left? Employee ID, is it okay? Right. Let us stick to this idea only. Employee ID is a primary key. Let us consider this employee ID as a primary key. Now the question comes. Employee ID cannot be repeated and can't be null. Sounds okay. But hold on. If I mark employee ID as a primary key in this table, so that means I cannot repeat that employee ID once again in this table. Yes or no? 1, 2, 3, 4 employee ID is there. Okay. In this table, can I repeat this one more time? 1, 2, 3, 4 somewhere in the same column. Can I repeat it? No, because if I mark this as a primary key, what does it mean? I can't repeat it. It can't be duplicated. It is unique and not null, right? So what is primary key? Unique and not null. If this is a case, unique and not null, and which table are we looking at? Payroll table. In May month, 1, 2, 3, 4 person, the employee gets the salary. June month also the same employee should get the salary, right?
Yes.
Yes or no? May month you got the salary. June month the same employee ID should be getting the salary, right? Yes or no? But if you mark this as a primary key, what will happen? In this payroll table, if someone, the database developer marks that as a primary key, what will happen to that employee? That employee will get paid only once throughout the career working with that company. Don't join that company. Yeah, sir, no, you can't work for the whole lifetime for only 1 month payment, right? Maybe it is 100 crore settlement, one-time payment. Okay, you can try that out. Yeah, that is not possible, right? But understand that something is just because sounding unique, you cannot directly call it as a primary key. Employee ID. I created this table intentionally. The moment you see the employee ID, you think what? Employee ID is a primary key. No, that is not the primary key. I'll tell you one more thing here. I've hidden that column. There is the same employee who got the bonus also. Yeah, possible in the same month with the same employee ID. Okay, tell me something. Every month when the employee gets paid, is there any new employee ID issued every month?
No.
New employee ID every month for that employee? No, right? It's the same employee ID throughout the career. Understand, here it is not a primary key. This is not a primary key. No, that is not a primary key. Take it off. Then what is the primary key here? Pay ID. Because every pay that you do, that comes with one unique identification number. That is a primary key, not employee ID. Then what is employee ID here? Before answering that, I want you to take a look at this employee table. Now I think you can easily say this. What is the primary key here? Employee ID. Perfect. It is a primary key here. The same employee ID 1, 2, 3, 4 will come here for multiple number of times. So what kind of a key is it? It's a foreign key. What is a foreign key? Foreign key is a primary key of some other table. Foreign key is a primary key of some other table. Foreign key is a primary key of some other table. Okay, what is a foreign key? It's a primary key of some other table. Yes. Okay. So this basically helps us maintaining the data integrity. I'll tell you why. If I want to process a salary for 8899 employee, 8899 employee, if I want to process a salary, it will fail. Why? Because if the 8899 employee ID is not there in the employee table, then how can you process the salary? You got the point. So if the employee is there in the employee table, then yes, you can process the salary for that employee. If that employee itself is not there, I mean, record itself is not there, then you cannot process the salary. You understood? Got some idea now? So just by looking at the column header, you cannot say something is a primary key. If I ask you, is it a primary key? You know what is the right answer for this? You need to ask me a question. Which table? Without knowing the table name, you cannot say something is a primary key or not. Aadhaar, is it a primary key? Aadhaar number, is it a primary key?
Depends on the tables.
Right, you should ask me in which table. When I ask you what is a primary, I mean, Aadhaar number, is it a primary key? Correct. Your question should be which table. Unless you know the which table name, you can't say it is a primary key or not. Aadhaar number in the Aadhaar issuing authority tables, it's a primary key. Why? Because they issue each and every citizen of India with one unique identification number. So it's a primary key for them. But the same Aadhaar number can be repeated in many other places. That is a foreign key there.
How can we establish the relationship between these tables, sir?
Right. That is part of the database development. How to establish a primary key and a foreign key relationship between the tables. Okay, in the database development, I'll show you the table designing and all. Okay, so there is something called references tab, and there we can establish a relationship in the model. Okay, there we'll understand. But theoretically, try to understand this, and then practically we'll do that. Okay, fine then. Okay, tell me. Customer ID. Is it a primary key? Which table? Perfect. Customer ID in the customer's table. Customer's table. Customer ID in the customer's table. It's a primary key. Excellent. In the customer's table, customer ID is a primary key. Okay. Transactions table, customer ID.
Foreign key.
Perfect. Why? Because in the transactions table, who buy those transactions? Customers. The same customer can visit us multiple number of times using the same customer ID. In the transactions table, if you mark the customer ID as a primary key, then what will happen? In the transactions table, if you make the customer ID as a primary key, what will happen?
We cannot perform transaction for multiple times with the same customer.
Correct. One customer can visit our store only once. Right? Then the business? Yeah, only once facade, right? Yeah. Business will go, will go for toss. Okay. Student ID. Which table? Oh, excellent. Student admissions table.
Primary key.
Primary key, because each and every student in the admissions, that person gets one unique identification number, right? Excellent then. Yeah, student admissions table. Student gets one unique identification number, right? The same student ID in the examinations table. Foreign key, excellent. Why? Because the same student using the same ID needs to take the examinations for multiple number of times. But what if in the examinations table we mark the student ID as a primary key?
For only one exam.
All students will be very happy. Why? Because all these students will have to write the how many exams?
One exam.
Only one, because in the examinations table, if you mark the student ID as a primary key, how many times each student can appear? Only once, because the system itself won't accept. Right? Okay. Laptop serial number.
Which table?
Okay, in the laptop manufacturing table. Primary key. In the service center table. Why? Because the same laptop with the same ID can go there to the service center for multiple number of times. This is the last example for today. With that, you will get a better clarity and you will never forget also. Vehicle registration number.
Which table?
Which table? Okay, RTA department, the Road Transport Authority who issues the vehicle registration numbers.
Primary.
Primary key, perfect. Why? Because each and every vehicle number, they issue one unique identification number, right? In the traffic challans table.
Foreign.
It depends on your talent and the skill. Multiple times, the vehicle number can appear as a foreign key in the traffic challans table.
Sometimes primary also.
No, it can't be a primary key in the traffic challans. In the challan ID in the challans table is a primary key. Each and every challan that is generated using one unique identification number, but multiple challans can be there for the same vehicle also, right? That means multiple times the same vehicle number will be repeated, but each and every challan number is unique, which is the primary key there. Understood? Got some idea now? What is the primary key, foreign key? You cannot say just by looking at the header, you cannot say it's a primary key. Most of the beginners, they do this mistake. Aadhaar number, the moment I say that Aadhaar number is a primary key, no, hold on. It depends on which table you are looking at. The same way, the payroll table, if I mark the employee ID as a primary key, what will happen?
The employee.
Exactly, the employee will get salary only once throughout the career. Got it? Now we got some idea what is the primary key, foreign key. Now the upcoming sessions are going to be little easy because you started understanding how the tables are designed, what is data normalization, what is data denormalization and all. One final question for you for today. You tell me as a data analyst, which data would you like the most or would you enjoy the most creating the reports? Is it the normalized data or denormalized data?
Denormalized.
Okay. I have the question is, as a data analyst or a reporting analyst, which data set you enjoy the most creating the reports? Is it the normalized one or is it the denormalized one? Online participants, what is that
Normalized one.
you like? What is that you like to create the reports using which data? Normalized data or denormalized data?
Normalized.
Normalized, okay. Others also please respond, use the chat window or whatever it is, you want to unmute yourself and you can say that answer. Which one you enjoy the most? Normalized, okay. Others also please respond. I want to see it from all of you. Please use the chat window and how many of you are saying normalized here? Oh, you all are saying? So, which data set you enjoy the most or you like the most to work with to create the reports, okay? Is it the normalized data or the denormalized data?
Denormalized.
Oh, you are saying denormalized. Denormalized.
Yeah.
Denormalized. Normalized. Okay. Online participants also, we go with the voting, okay? Whoever says the highest, we'll go with that, okay? But so far, I think normalized. 4 normalized, 3 denormalized, and others are also coming up with their answers. I think they are still thinking which one to answer. Yeah. Okay, here we go. Tell me something.
So, sir,
Yeah.
so to understand your question, when we
Hmm.
work on normalized question, we need to work with multiple tables.
Correct,
So
yeah,
it takes little time, but
yeah,
denormalized it takes easy. That is
right, yeah,
so that
yeah.
easy
So,
to work on the table, but to like and to
yeah,
learn, we need to be
Hmm.
working on normalized.
Okay. I understand your point, okay. But tell me something, you all want the work to be complex or easy?
Easy,
Okay. Honest, huh? Be honest, don't give me that interview question related answers. Huh? I want to
easy,
work in a very challenging place where I want to prove myself and I can make wonders. No, don't say that, right? This is not the interview, okay? We all want to work in a simple manner, right? Easy things, right? Okay, cool. So even if you ask me the same question, I would vote for denormalized only. Yes, something, someone rightly mentioned in the denormalized data, everything is available in one place. Then why do you want to put yourself in troubles? Something is available in the denormal form, directly start working with the denormal form, right? Why do you want to go with the normalized form? Wherein you will have to again check multiple tables and find out what is common there and then write the lookups or write the joins or write the relationships between the tables. Keep it easy. As a data analyst, we prefer the denormalized data. That's the reason in the OLAP, the ETL developers, they try to reduce the number of tables and bring the data as close as possible with limited number of tables. Of course, it is still normalized only, but not more number of tables, less number of tables. Understood? Right? Yes. If you ask me the same question, my answer is going to be denormalized data. Right? Okay, fine then. Questions? Yeah, fine.
The earlier answer is any kind of data.
Huh?
I am looking at that.
Any kind of data. Yeah, I'll tell you that is a reality actually. Because once you join a company, you can't expect only I want the data only in this shape. No. This is what I always say. People think that the real-time data sets are the most beautiful formatted ones. No, that is not the reality. That sad reality is the worst, dirtiest data you get to see in the real time only, right? You give a clear instruction to the users, you need to perform A, B, and then C. You give a very clear instruction, perform A, B, C. You know what they do? They exactly do C, B, A, right?
True.
Then it comes to us in a very dirtiest format. And your manager asks, okay, where is the report? And you say that, user centers incorrect data. And then your manager says, okay, you're a data analyst, right? Fix it and get the report ready. And ultimately it comes to us on.
Yes.
So we should be ready with to work with any kind of data. That is true. But to like the most is denormalized data, right? Fine, and so that's all for today. And tomorrow we will start our presentation. I'll take you through the SQL fundamentals one by one, right? So step by step, it is all about the basics of the SQL. What is SQL? What is database? How it looks? The images and a few things are there like the database structure, right? And a few things are there. And tomorrow I'll take you through how to install SQL Server. Done? Okay. So you need to do a small exercise today. You need to find out 2 primary keys and 2 foreign keys with the examples. For an example, I can say customers table, customer ID is a primary key. The same customer ID in the transaction table is a foreign key. So that's how you need to write 2 lines. 2 lines. What are they? 2 with 1 or 2 primary keys and 2 foreign keys. In which table it is called as a primary key and the same primary key where it is called as a foreign key. So 2 statements I want. And you can post that in the WhatsApp group. I hope all of you are part of the permanent group. Please do that, right? Post it there and also download the material and be ready because tomorrow onwards this presentation is very much needed, right? Tomorrow we are going to discuss this presentation. Done? Great. So thanks everyone for attending today and I'll see you all tomorrow same time. Join by 6:40. Yeah. Thanks everyone. Bye.
Thank you, sir.